Hey everyone, so this is going to be the first video that is going to be completely designated to cover the different kinds of carbocation rearrangements that we can have in SN1, okay? I'm going to assume that you're already good with SN1. If you feel comfortable with SN1, by all means watch this video. If you feel uncomfortable with SN1, you may want to check out the video on SN1 and the mechanism before you look at this video, okay? So as I said, in SN1, we get a carbocation intermediate, and that intermediate can go under rearrangements, okay? One of the rearrangements that can happen is a hydride shift, okay? We can also get methyl shifts and ring expansions, and each of those will have their own separate videos to cover those topics, okay? All right. So the very first one here is I'm going to do an example. I think we're going to make this slightly longer as well. Yeah. So I'm going to do this example. So chlorine there. Okay. So we have 1, 2, 3, 4, 5, 6, 7. We have 7 carbons. So if I put this through with water, right, then what I'm going to be getting, you would think that I would get OH here, and then I also get OH there on a dash, right? No, that's not what I get at all. What I actually get is this. So my methyl group on a dash, OH here. And then I also get the enantiomer of that. Which is this on a wedge and OH on a dash, right? Let me just count my carbons. Okay, yeah, looks good. So these are the two products that I get. Okay, I do get the other one that I drew earlier, right? I do get the one where I just have OH replacing the chlorine. I do get those, but that's very minor products. Okay, so what I've drawn here are the major products. Okay, so our mechanism is going to be explaining how we get these products, what's going on here. Okay, so let me go ahead and write this out. So if you know something about SN1, you'll know that the very first step of SN1 is that carbon halogen bond breaks, right? And we're writing the mechanism here. Okay, so just so we're clear. Okay, so carbon halogen bond breaks. Then what do I get? Well, I get a carbocation here, and then I get my chlorine, right? So Cl minus. And then remember that a carbocation is more stable whenever it's a higher degree. So what does that mean? Well, this carbocation here is 2 degree, right? That's a 2 degree carbocation. But it would be more stable if it was 3 degrees. So if I had a carbocation here where it could be 3 degree, it would be more stable, right? So if I have the ability to move the carbocation to an adjacent carbon, right? So in this case, that carbon's adjacent, right? So I can move it to an adjacent carbon. If there's an adjacent carbon I can move it to, it's gonna move. So in this case, we can do it by doing a hydride shift. Okay, so this hydrogen is going to go with its electrons and it's going to move to that carbon. Okay, so what that means is that I just gained another hydrogen on here, right? I just gained another hydrogen on that carbon. So this carbon is no longer charged, okay? The one that did have a positive charge is no longer charged, but this carbon right here, that carbon just lost a bond, right? It just lost a hydrogen. So now this carbon here has a positive 1 charge on it. Okay, there's a positive 1 charge on that carbon now. So now you'll see I went from 2 degree to 3 degree. That's exactly what I wanted to do, right? So that's very good. That's exactly what the molecule wants. So beautiful. Okay, so now our water is going to come in and it's going to act as a nucleophile, right? And and I'm also going to just be clear and write that this is a hydride shift over the arrow. Sorry. So hydride shift occurred there, right? Anyway, so nucleophile is going to come in and attack. Now it just proceeds the same way that SN1 proceeds, right? So after the nucleophile comes in and attacks, then we get this with our positive charge here, right? And then another one of our solvent molecules, another water, is going to come in and it's going to take that hydrogen off, which is going to move those electrons there, right? And if this is confusing, then like I said, I would check out the other video on SN1. So our two products, I drew them earlier, right? We get this one, OH, and we also get this one. Remember, it's SN1, we get both of these. And then our byproduct is going to be H3O plus as well, right? And I'm done. Okay, so this is the mechanism that explains what exactly is going on with this hydride shift, all right? So that's all we're doing in hydride shifts, okay? We're just increasing the degree of the carbocation, okay? That's all we're doing. This would also happen, just as an example, if, I'm not gonna do the mechanism for this one, but just so you understand, let's say that I have a ethyl group here, and if my chlorine was here, well, chlorine would leave, right? So then that means that I would get a positive charge here. Well, there's a hydride that can move here, right? So that hydride's going to move up there. And then that means that where this ethyl group is, I'm going to get a positive charge where that ethyl group is, okay? So just know that it doesn't have to be a methyl group here, right? It can be any group like that, okay? That it can move to, all right? I just wanted to make that quick caveat there known. So now I'm going to move over just slightly here so we can get a little bit more space. And we're still talking about hydride shift, right? And I just want to do one more example with the hydride shift, okay? So in this case, I'm going to be doing a bit of a caveat on the hydride shift, okay? So let's take a look at this one. I wanted to think of a good example, sorry. Actually, let me back this up, sorry. Yeah, that's what I want. Okay, so we're going to use this to go through, and I'm just going to use water again. Water's simple to use. It requires less writing. So 1, 2, 3, 4, 5. There's 5 carbons in this. So 1, 2, 3, 4, 5. And you would think, again, that I get OH here, right? But no, that's not the case. And the other thing is that this is a primary alkyl halide, right? Primary alkyl halides, if you remember from the SN1 video, they suck. They're really bad at going through SN1 reactions. So how does this even react in the first place? Well, again, in this case, I'm not going to be getting it there. I'm going to be getting my OH here. And I'm going to be getting my OH on the same one, but just on a dash instead. So these are my two major products. So how does this happen? Well, I'll show you. So remember that I said this is a bit of a caveat, okay? This is a bit of a caveat. So remember that a 1 degree carbocation, not stable, right? Very unstable. So the molecule is going to do everything in its power to not form a 1 degree carbocation. So how is it going to do that? Well, The hydride shift is going to happen, but remember the first step is that bromine leaves, right? Well, it turns out that the 1 degree carbocation is so unstable that bromine can't leave and form that 1 degree carbocation. So the hydride shift and the leaving is going to occur at the very same time. Okay. And this is going to happen with every shift. If I have a methyl shift and it's going to be shifting towards where a 1 degree carbocation would be forming, the shift and the leaving of the leaving group is going to happen at the same time. Same thing with the ring expansion, okay? And in each of those respective videos on methyl shift and ring expansion, I'm going to talk about that, okay? Just to be clear. But this is the caveat, okay? I think this is rare. I don't think you're going to see this very often, but just in case it's on the exam, here we go. So, like I said, the hydrogen is going to shift to this carbon at the same time that this bromine leaves. So bromine's going to leave and the hydrogen's going to shift, okay? And I'm just going to write hydride shift over the arrow. And I think it's nice for you to write that because if someone's grading the exam, then it's more clear what's going on there for them. So now I get my carbocation here, right? That's my carbocation. Then what else did I get? Well, I also get Br minus, right? Because Br minus just left. Okay. So, okay. And then now the reaction just proceeds normally again, right? Just a regular SN1 reaction from here on out. So H2O is going to go in there and act as a nucleophile. And then that's going to leave us with this, right? And then so we have to go through the deprotonation step where water is going to come in and act as a Bronsted base. So it's going to do that and that. And then we're done. And we get our two products. My other product is just on the opposite side, right? And then what else do I get? I also get H3O plus. Right, H3O plus as well. That's it. So this is what happens in a 1 degree carbocation. Well, not 1 degree carbocation. This is what happens if a 1 degree carbocation would have to form, which it never does form. So that's why the shift happens at the same time. So I think these are the two things that we need to understand whenever it comes to shifting. So in the next video, we're going to talk about methyl shifts. And in the video after that, we'll talk about ring expansions. All right. So again, hopefully this was helpful. I appreciate you watching, and I will see you next time.